Hello everyone, this is Carlos Galera. Welcome to our sixth session in Built Asset Management. Today we will be covering data analysis and asset management. Well, first of all, I would like to introduce the overview of this session. Basically, the objectives in this session would be to explain the origin and evolution of data science discipline, and by the end of the session, you will be able to understand the impact and relevance of data analysis in the built environment. Finally, we will reflect on the applications, importance, and advantages of data science in built asset management. In the first part of the session, we are going to analyze the impact of data analytics in the built environment. First of all, and continuing the teaching material from week number 5, we are going to set the scene of the phenomenon of digitalization. Well, the development of digitalization is clearly connected with a significant technological progress, something that is called in literature the fourth industrial revolution. This technological revolution is connected with the massive improvement in sensors, communication, and data storage. And this improved technological capability is influencing the way companies create the value in all business activities. The second point to consider, more connected with the built environment and project management, is that according with the literature, project management needs to reorient its research paradigms and industrial practice in order to understand better the generation of value in projects. So, by combining these two phenomena, the important technological progress and the need of reorientation in project management, we can state that we are in a key moment in which project management discipline should rethink their view of value creation and how to manage projects in a digital economy. As you already know, the engineering and construction sector is an important industry. It is worth more than $10 trillion a year, and while its clients are increasingly sophisticated, the sector itself remains under-digitized. The use of computer and software and digitization are emerging to have a wide impact on the way that the life cycle of physical built asset is managed. So that's the point because we are talking here about digitalization. Because the digital process can impact very importantly the built asset management. So a shift is coming. The different stakeholders across project, let's say constructor, clients, operators, service providers, can't longer afford that the big data, the artificial intelligence, the digital twins are technologies which belongs to other industries. And we all need to integrate these new technologies into the construction industry. But there are still challenges around the use of data analytics in business. It's true that the companies have now more data than ever at their disposal. But the problem is to achieve meaningful insights from that data. This is the big challenge. I mean, we have data, but it's still complicated to convert this data into useful information, which is valuable for the business. So we can identify three main challenges. The first one is that we need to evolve from a knowing culture based on experience to a learning culture based on proactive processes. The second challenge is to find a set of tools and the right organizational forms that enable the different companies to generate the value through the process of data analysis. And the third important challenge is about trust and data privacy, mainly the problem about to share or not to share data, or which kind of data can be shared and which kind of data must be kept at company level. If we delve into data analytics, we need to understand the different types of data. Roughly, we can distinguish two different types of data. The structured data, like database, information from ERP or CRM, and the unstructured data, which is basically text, audio, videos, other type of data that can be gathered by sensors. Keep in mind that more than 80% of all the data generated today is considered unstructured, and this number will continue to rise with the prominence of the Internet of Things. What does it mean? Clearly, the structured data is much easier to proceed and to gain meaningful insight from them. However, the unstructured data is much more difficult to manage and to analyze. However, as I said, the unstructured data is much more common. In this figure, you can see the evolution of data analytics towards a more proactive approach. As you can see at the beginning, it was the report to understand what happened. And we start to use statistics to analyze why did it happen. In the next step, we are able to monitor in order to understand what is happening now. So we can use dashboards to monitor the information. But the significant step is from the monitoring to the predict phase. We are able to make predictions to understand what might happen. And more recently, we are entering in this stage of simulations by the use of digital twins. Basically, what will likely happen? We are building model scenarios. So the shift is from reports to monitor, and then from models to predict to digital twins and model scenarios. It's also important that we understand the classification of data analytics because sometimes there is confusing information about artificial intelligence, deep learning, machine learning, etc. The concept of artificial intelligence englobes all the other concepts about machine learning or deep learning. So basically, the artificial intelligence provides algorithm solutions to complex problems that usually are solved by humans by achieving a near human levels of intelligence. Within the artificial intelligence, we can distinguish the machine learning, which is basically a subset of artificial intelligence. The machine learning are the algorithms and processes that are the ability to learn. By using past data and experiences, they are able to predict outcomes and improve the processes. And finally, the deep learning is a subset of machine learning, which is basically the specific class of multilayered or the use of neural networks. And now the question is, what is the level of maturity of data analytics in the built environment? Some important people in the industry, like Sir John Armitt, say that data now is as important to UK infrastructure as concrete or steel. This gives you an idea of the significant importance of data for the construction industry nowadays and in the future. However, we need a more established transition from the traditional lesson learned when we learn from past projects based on the documentation and reports to the data analytics in order to be more proactive. And the second transformation, which is already more advanced, is from the paper-based workflow to the digital thread, to the digital workflow. In that sense, the use of BIM, as you learned last week, it's very, very important. But the reality is that the construction sector is at an early stage in terms of maturity. As you can see in this index provided by McKinsey, uh, we can find construction at the bottom of the industries in terms of digitalization. And as you can see, in terms of asset, the application of digitalization is still in its early infancy. You can see in this chart that the AI adoption and demand trajectory for the construction sector is not much better. It's not very good compared with many other industries. So it means that there is still much work to do if we want to digitalize the construction sector. In terms of the collection of data from projects, we can obviously to analyze the BIM data, the design, your progress, cost, communication, project management data, etc. But also we can gather data from the job site by using wearables, mobile devices, sensors on equipments and material, images and measuring from drones. So the options to gather data are already there, and actually many constructors are practically drawing in data. But what is the problem? That they don't have the right tools to analyze the data in the ways that they are meaningful in order to positively impact the project. So it's clear that a digital strategy is needed. So first, we need to be aware where the AI solutions are beginning to emerge in construction today. It means where the use of artificial intelligence algorithms are already working. Also, we need to explore the application of this AI and the use cases that have already made an impact in other sectors such as financial sector, such as manufacturing, etc., and try to understand how we could apply this into the construction sector. The point to consider as digital strategy is to assess additional machine learning algorithms and to check their potential in the engineering and construction industry. If we look at the areas of application of data analytics and big data in the construction industry, we can identify many different areas. Here we have identified maybe the main five in which we can use the data analytics, but as I said, you can apply data analytics in many different areas. One area where we can see clearly the impact of data analytics is in project planning optimization and how to continuously improve the planification of the project while the project is running. Also, the application of predictive technology can forecast project risk, constructability, and the structural stability of various technical solutions. In addition, the artificial intelligence is a quite capable assistant to project managers. Obviously, artificial intelligence is not able to substitute nowadays a project manager, but can be a very good assistant. In terms of supply chain, the digitalization can help in the optimization of this supply chain for materials and inventory management, and the image recognition technology. It's very useful to reduce the risk and provide better solution for safety management in projects, in construction projects. You know that risk and safety is a big concern. Also, we can use technology in the definition of quality control and claims management. For example, by identifying defects in execution by comparing a physical model and digital models, or at early detection of critical events like bridge failure. In Moodle, you have the opportunity to watch a very interesting video about the use of digital technologies and digital twins for bridge maintenance. And here you have some general conclusions on the application of business analytics in the built environment. The first one is that the digitalization and modern business analytics requires new research paradigms, business practice, and business models in order to be successful in our industry. And in order to do that, we also need to overcome some important challenges. One of the challenges is to increase the trust to share data by using, for example, blockchain technology. Also, we need to increase the collaboration between the different stakeholders involved in project and make sure that data do create value. But it's clear that business data analytics is going to be a key factor in the future of project management and the construction sector. But we need to be aware that still much to be done. We need to learn from other industries that already have an higher degree of application of these technologies. And finally, I would like to point out some opportunities and risk. In terms of opportunities, we can reduce the construction and operation cost. We can provide a more effective design, and of course, connected with this module, better asset management and the operation and maintenance. Also, we can achieve a safer and faster work in the work site, and improve collaboration um, between the different actors in the project. But also, we need to consider some risk. First one, obviously, is the cybersecurity risk or the cost to develop some complex technologies such as digital twins, and a very common problem in technologies that are being developed is that sometimes we can overselling expectation about what technology can do. And finally, other important problem is the insufficient workforce upskilling, and that's the reason because new masters and new programs connected with the use of technology in construction are being developed quite recently.